Now, what is the depth from free surface? H, and everything will measure from here. If you move down, as if you move down inside the liquid, depth will increase, will be positive. So this will be positive. This will be negative. That same thing. That's why I made this negative. That's the reason. Okay, let's come for this. So what is the pressure at these points? So what is our primary question? Our primary, the same liquid. Density rho, 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 and rho. I'm going to say that P1 is equal to P2 is equal to P3 equal to P4 is equal to P0 plus rho G H. All are having same level. The liquid is up to same level. So how come? Yes, we have to. If we are good in mathematics, or in fact we can prove it. Or the best thing what we can do is like what the force exerted by the liquid here. So what I do is like I know the, see how do I can, so two methods are there. What is one? I'll take help of mathematics. Using that, I'll calculate the force exerted by liquid on the bottom. Okay, fine. Then that normal force per unit area will become pressure. That's the one thing. Next again, I'll go for lab. I know this container. What is the weight of this container? Empty container. Then I'll fill up a liquid. Then I'll measure it. Okay, that's from that what pen I'll get the weight of the liquid. Okay, clear this. I know here atmosphere, P0. Even the liquid, the walls will exert force here. From that what happen, I'll do analysis, and again with the help of that I'll calculate the force acting on this one with all the mathematics, the lab information available. When I go and check it, no, the pressure at all these points will be same. Of course, there is it force at all these points are same? No. Here the force is F1, F2, F3, F4, but the force per unit area will remain same. The simplest thing, force per unit area will remain constant at the bottom. So therefore the pressure will be same here. It's independent of what, like shape of container. It just depends only on the depth. Since the liquid is filled up to the same depth in both all four containers, the pressure is going to be same. Of course, I think proving mathematical will take more time. Maybe at the end of this chapter, after you learn how to calculate the force exerted to liquid on the side walls, maybe you can try. But time being what, I'm just doing one thing. The force per unit area at the bottom of surface will be same. So therefore, the pressure will be same. And according to the manometric equation, P0 plus rho GH. If I write it, so the pressure is going to be same here. Now, what is the so this is about, it's independent of shape of container. We should bother only about the depth here. I used the word manometer. So let me show that. What is that manometer equation? Already we have, no? Let me take this. No, this is H equal to 0. So I want the pressure at 0.1, pressure at 0.2. So what is the depth? This H1. What is the pressure of this? Let be H2. No, pressure at 0.1 and 2, that one. So there's a free surface. Free surface, if you want to show thick line. This is. What is the pressure at this point? Will be P0. So I'm starting like this. P0, or call this as 0.3. So pressure there P3. Then if you move inside the liquid, vertically down, the gauge pressure should be positive, plus rho G H1, and where you end up, that you should write negative equal to 0. What is the pressure at 0.3? Free surface. So it should be Okay, now sir, between 3 and 2, I'll write it. Okay, then proceed in the similar way. P3 plus rho G, sorry, P3 plus rho GH2 minus P2 equals 0. There's a pressure at 0.2. Pressure between 1 and 2, can I find out as P1 plus rho GH minus P2 equals 0. So P2 equal to P1 plus rho GH. What is H? H2 minus H1. You can find out this one. So, but why you always started from 3? Why can't you start from 2? Yes, I'll start from 2 also. Or P2. If I move up inside the liquid, it should be negative, no? So minus rho GH2 minus P3 equal to 0. Okay, this one. So P2. In a reverse way, completely. I'm writing or. Means there's no rule that you should always move down inside the liquid. It can be, you can also. So similarly here, P1 minus rho GH1 minus P3 equals 0. This is called like a writing manometric equation. So where you begin positive, where you end up, that should be negative. And if you're moving inside the liquid, it should be positive, the depth. And if you move above the liquid, it's called like a height. I should be represented as negative. So if you measure the H, if it is this direction, it will be positive. If it is upward, it will be negative. I think this is the, officially I can say that chapter is over, because with this you can proceed everywhere. This is enough. What all numericals, what we do, just revolve around this one only. Writing manometric equation.